In this lesson, I'll show you how to solve solution stoichiometry questions. This is question number 1. The question reads, what volume in liters of 0.150 molar of KCl solution is required to completely react with 0.150 liters of a 0.175 molar lead nitrate solution according to the following balanced chemical equation? At first read, there's a lot of words and there's a lot of numbers provided. So what I like to do in a situation like this is highlight everything that's important. Let's start with the concentration of KCl. We're told that it's 0.150 m. I'm going to write that down right underneath where I see it. So I have the concentration, I'll represent it by the letter C, although in other videos I've represented it by the letter M in square brackets. Either or works. C is equal to 0.150 molar. And remember, molar is a concentration of moles per liter. So I'll write down moles per liter. We're also told information about the following compound, lead 2 nitrate. And we've been given its concentration of 0.175 moles per liter. And the volume. The volume here is 0.150 liters. What we have to find is the volume of KCl. And to find the volume of KCl, we need to use the relationship where the concentration in molars is equal to the number of moles, which is represented by the letter N, over V. So I need to somehow find the number of moles of KCl, and then I can use this formula along with this number to find the volume. So what I'll have to do is find the number of moles of this compound and compare it using a ratio to this compound. That will give me the number of moles of KCl, and then I can use this formula to find the volume. Here's what I mean by that. So I'm going to use this formula for these two numbers to find the number of moles. I'll replace 0.175 with C is equal to N over my volume of 0.150. Now if I'm looking for N, I need to multiply both sides by 0.150. This is a simple algebraic problem. Multiplying both sides by 0.150 gives me, this cancels out, and the number of moles is equal to 0.150 times 0.175. The number of moles here is 0.02625. I found the number of moles. I'll place that number right here as well. Now, like I mentioned, I need to do a ratio. In this balanced chemical reaction, there's one molecule of this compound versus two of this. So my ratio will be 2 to 1, and I'll write the number of moles, which I found for this compound, right underneath this 1. And I need to find the equivalent number of moles for this compound. So setting up my ratio, I can find x by cross-multiplying this with that and that with that. So I have 0.02625 times 2, and that gives me my x value. I get 0.0525. X is equal to 0.0525 moles. That's the amount of moles of KCl. Now using this formula once again, along with this concentration, I can find the volume. I'll write this number here for clarity. So I have 0.150 is equal to the number of moles that I just found, and I'm looking for V. I can find V by multiplying both sides by V first. The V's on the right side go away, and we have V times 0.150. Dividing both sides by 0.150, I end up with V is equal to 0.0525. Now, a lot of students just memorize the steps. So if you're not familiar with the algebra that I just showed, just remember that if you want to find the volume, you take the number of moles and divide it by the concentration. Also, there is a triangle which you can use to easily calculate the number you're looking for. Now, I'll divide these two numbers out, 0.0525 by 0.150, and that gives me 0.35 liters. 0.35 liters, which in milliliters is equal to 350. The question, although, doesn't have a requirement, so I'll just write down 0.35 liters. So to answer this question, what volume is required? We need 0.35 liters of KCl in order to completely react with this amount of lead nitrate. And there you have it. That is how to solve solution stoichiometry questions. Make sure to watch question 2 for another example.